Hello everyone and thanks for watching Edupedia World videos. This video addresses basic overview of limits. Limits are the basis of calculus. As opposed to algebra where a variable is considered to have a fixed value, in limits we allow a variable to change continuously and study how a function value changes. Consider a circle. Let an equilateral triangle be inscribed in it. Suppose I say the circumference of the circle is approximately equal to sum of length of three sides of triangle. So how can I justify that? Okay, let's consider a four-sided polygon. What if I increase the number of sides of polygon further? As the number of sides become larger and larger, the polygon get approximated to circle. So I can justify the circumference of circle to be the length of side of polygon provided number of sides of polygon is pretty much large. Here comes the concept of limits. Okay, we inscribed a triangle, then the circumference. Let us denote the circumference by capital letter C. C will be approximately equal to 3 into S in this case, provided S is the length of this triangle, sides of this triangle. Okay, now consider the case with square. Then the circumference C will be approximately equal to 4 into S. So when it is an n-sided polygon, we can say that C will be approximately, that is circumference of the circle will be approximately equal to n into S. We can observe that as the number of sides increases, the accuracy of circumference defined as n into S also increases. So let's say that number of sides tend towards infinity. That is limit n tends to infinity n into S, some suffix n. So this is the abbreviation for limit. This will be equal to the circumference C. Okay, seeing this, naturally we'll have a doubt. So as n tends to infinity, this term will be infinity. So why not the circumference also be infinity? So here we can observe that as the value of n increases, here n is 3, here n is 4, here n is 5 and so on, here n is 10. Okay, so as the value of n increases, the length of the sides, that is this length, get reduced and reduced and reduced. So as the value of n increases, the value of Sn get decreased. So this product will have a finite value, and that finite value will be the circumference. Now let's have a broader view on limits. Okay, you are given a 24 centimeter wire, and you are asked to form a rectangle whose area is as large as possible. So what will be the dimension the rectangle should have? For that, let W be the width of the rectangle and L be its length. Now let's draw the rectangle here. So this will be W width and this will be length L. Okay, so what will be the perimeter of this rectangle? Perimeter is the sum of sides of this rectangle. So perimeter equals 2 into W plus 2 into L. That will be equal to 24 centimeter, because we are forming this rectangle using a 24 centimeter wire. So the maximum perimeter it can have will be 24 centimeter. Okay, now what will be the area of this rectangle? Area A equals product of length and width. Okay, so what is length? From this equation we have length equals 12 minus W. So length equals 12 minus W. So area will be 12 minus W into W. That is, area equals 12W minus W square. Okay, using this model for area, we can experiment with different values of W to see how to obtain the maximum area. And after trying several values, it appears that the maximum area occurs when the width W equals 6. Now let's show this in a table. When width W equals 6, we have the maximum area, which is 36 centimeters square. In limit terminology, you can say that the limit of A as W approaches 6 is 36. That is, limit W tends to 6, A equals is 12W minus W square. So limit W tends to 6, 12W minus W square will be equal to this 36. Okay, now let's draw the graph for this. So this is the function 12W minus W square. When the width W equal to 6, we have the maximum area, that is, the function reaches its maximum, which is 36. Okay, we can see that as we approaches this limiting value, either from right hand side or from left hand side, the function tends towards 36. That is, limit W tends to 6 plus A equals 36, and limit W tends to 6 minus A equals 36. This positive and negative indicates the direction in which we are approaching the limiting value. As we are approaching the limiting value from right hand side, we uses a positive sign, and as we are approaching this limiting value from left hand side, we uses a negative sign. Okay, now without drawing the graph also, we can compute the limit by direct substitution. That is, limit W tends to 6 of A equals limit W tends to 6 of 12W minus W square. We can substitute for this W. As W tends to 6, we can write 12 into 6 minus 6 square. That is 72 minus 36, which is 36. Let us define another function. Let f of x equals x minus 2 when x is less than 0, 0 when x equals 0, and x plus 2 when x is greater than 0. And now let's find limit x tends to 0 f of x. Okay, now let's consider the graph for this function. This is y-axis and this is x-axis. So this will be f of x and this will be x, and we can plot the graph here. So let this be origin 0 0, let this point be 0 2, and this point be 0 minus 2. So the graph will look like this. This is f of x equals x plus 2, and this is f of x equals x minus 2. Here we put a gap in the function to show that it is not included in the graph. Here also we put a gap because at x equal to 0 the function is defined in such a way that f of x is 0. So at x is equal to 0 f of x is this. When we are approaching x equal to 0 from right hand side, that is we are approaching x is equal to 0 from right hand side, we can see that the function f of x is approaching positive 2, that is limit x tends to 0 from positive side, then f of x equals positive 2, and when we are approaching from left hand side, this is from right hand side, when we are approaching from left hand side we can see that the function f of x is tending towards minus 2, that is when limit x tends to 0 from left hand side f of x equals minus 2. Therefore left hand limit not equal to right hand limit. So we can say that limit does not exist for f of x at x equals 0. Here limit does not exist for f of x at x equal to 0. This is the basic overview of limits. Thanks for watching.